Hello, everyone. Let's get started. Today's webinar is going to be about the history and the behind the scenes of Seeds for Bees. So I'm really excited because we have not our latest hire anymore because we do have someone new, but a recent hire of ours, which is Tom Johnson. And Tom, you have a really interesting history with Seeds for Bees. You've been with us since the beginning, working with on the cover crop side. You used to be our seed supplier.
Yeah, I was first introduced to Pam basically when they had a kickoff meeting in the spring of 2014. So the company I used to work for was the main supplier for Seeds for Bees since basically they started using commercial seed in California.
Yeah, mean, I'm really excited about listening to the stories that you have because it's so valuable that you know so much about Seeds for Bees and the background of Seeds for Bees. Um, for those of you who don't know, I'm Stetson. I'm Stetson Maldonado. I'm the manager of the Seeds for Bees program, and Tom is our grower relations manager. And we will be talking about the history of Project APISM, of Seeds for Bees, and then we'll be diving into the behind the scenes. So you'll be getting to see what goes into making Seeds for Bees happen and our cover crops. To start off, Project APISM was founded in 2006 by beekeepers and growers. It was actually largely in response to colony collapse disorder. If you guys remember that, it was a big issue. Bees were dying, people were scared, and a lot of beekeepers and growers wanted to have control over the research, in what direction it went in, what questions were being asked, what resources were being provided, um, and not basically to have that control of fixing the issues that they were seeing on hand. And the mission is driving and supporting science to deliver innovation for honeybees and bee businesses. So there's a lot of research that we do and continue to do. We've funded just over 12 million in 197 projects, research projects. We provide a lot of resources such as guides and videos, and then forage, and that is the Seeds for Bees program. I forgot to update this slide. We've planted a few more acres than this, but we've got just over 100,000 acres since our inception. So this was the cause of what created Seeds for Bees, is because we're losing bees. Not Seeds for Bees, Project APISM, because we continue to lose bees. As you see here, 2008 is when colony collapse really started going. And that blue bar is the winter losses. So these are bees that were lost during the winter months. The yellow one is during the summer. And originally, we used to be seeing our greatest bee loss in the winter just because it's cold, bees run out of food, a lot of stuff happens. But we have more issues than we used to, which is why the increase in losses, and we also started seeing summer losses. So if you follow it down to the end of 2024, our losses continue to increase, and that red bar is a sum of all of the losses. So it's summer and winter. When this graph gets updated by, I'm trying to remember who made this. I think it's the Apiary Inspectors of America. You'll see that that red bar will actually go over the 60% because a lot of beekeepers were losing 62% of their colonies last year. So this is how bees move around the United States. You can see that the vast majority of them end up in California. This is during the late winter, so January, February. Nearly 90% of our nation's bees are brought to California just for the almond bloom. And from there, they go back throughout the United States. A lot of them go from almonds in California up into apples in Oregon and Washington. But this map is important because it explains why Seeds for Bees focuses in California. So we started off with a cover crop comprised of a plant called rapini. And in that first year, 2013, we planted 2,119 cover crop acres, and we had 109 participants. We have definitely grown from that first number. This year, we planted just over 20,000 acres of cover crop, which is really exciting. So Seeds for Bees was launched in 2013 with an emphasis of planting cover crops in almond orchards. And if you think back to that map, it's because the vast majority of the nation's bees end up in almonds right in the beginning of the year when bees are coming out of hibernation. So Seeds for Bees' mission was to increase the adoption of pollinator-friendly cover crops, um, which provide forage for managed bees. And this is largely because a lot of the research that Pam and other organizations have come up with is that nutrition is a big factor in why we're losing so many bees every year. So that is why Seeds for Bees was created. Before we go into the behind the scenes, I wanted to say a big thank you to our donors. Seeds for Bees is actually 100% funded by donations, so there's no government money involved in Seeds for Bees. This is really great because our program can stack with any state or federal grant that people may receive, and they don't have to worry about losing that grant or having interference because of it. But also, if you're interested, you can scan the QR code to the right to donate and keep our program going. We would be super grateful for anything you can give. All right, let's get into the behind the scenes. So a lot of what we do is guided by research, and there's two recent studies that came out that is change or guiding how we do cover crops this year and into the future. The latest one, I believe Project Apisim helped fund this one, but it was research on brassicas and how they affect honeybees, not just from when they are blooming, but also throughout the year. So there's some cool info that we found. Colonies which had access to both almond and brassica cover crop flowers had better overall performance in most of the years of the study. Brassicas also complement the amino acids in pollen. So amino acids is they're the protein content, and every plant has its own offering of amino acids. So none of them are going to be the same. And it looks like, according to this study, that the amino acids in almond pollen cover what's missing in brassica pollen and vice versa. So it makes for a more wholesome diet. And then what was really fascinating is the colonies from the treatment group were typically larger throughout the entire year and had better winter survival capabilities, even when they were no longer in these cover crops. So they only had access to these cover crops in the very late winter, and it affected them throughout the entirety of the year, all the way into the following winter. We will be putting the link to this article, if you're interested in reading it, down in the description below. The other study, I don't think this one has been released yet, but it was by Dr. Antony Melathopoulos from Oregon State University. And he took a variety of commonly used plants in cover crops and evaluated them for their pollen and nectar. And we'll be adding some of those plants to our cover crop mixes this year. And we are currently testing other ones to see how well they perform in our blends. Plants which stood out in this study, or this trial, sorry, were some types of brassicas, Lacey Phacelia, California poppy. Fascinatingly, California poppy does not produce nectar, but it produces an incredible amount of pollen, and pollen is what's important for protein needs of pollinators. And then there are multiple nemophillas, so those would be things like baby blue eyes and five spot. And there were some others that I didn't list here. So we're going to go from the research into cover crop design. So Tom is going to talk about what goes into designing a cover crop and the steps that go into that.
Thank you, Stetson. Having designed cover crops for a wide range of things, there's a few things basically that the first question I would ask someone is, what do you want to get out of it? What do you want to accomplish? And in our case, we're trying to feed bees, and at the same time provide the grower with also some soil health benefits and that type of stuff like that. So the list here, basically, affordability comes to the forefront when you're buying that seed. If it's the best thing since who knows what, but you can't afford it, you're not going to plant it. So we would look at affordability, and the other one that goes with that is availability. Um, there's been many times where something great came out, it worked great, we showed it off. The next year, no one had produced any seed for it, or there was a seed crop failure somewhere, and you would run into that. Oh, we got to shift a little bit, and we have to use something else. So we were always trying to keep in mind what would do a similar thing type of that. The life cycle, or the growth period, the flowering, basically, for I would say over 95% of cover crops done in California, and especially in almonds, are going to be what we call a cool season cover crop. They're going to be planted in the fall. They're going to utilize rainfall to germinate, emerge, establish, and grow, and basically would be maturing in the spring when they're going to basically bloom, start to fill seed, and that's basically when you would manage them, terminate them, smash them, mow them, do whatever you're going to do to them type of thing. So back into that availability type, the life cycle we were looking at was like we were looking for as early a flower as we can get, because our California winters have never been uniform. So we were always trying to make sure that we would have stuff that would flower. And if we were working on something we wanted it to reseed, you definitely wanted it to flower as early as possible so that it had as much time in that spring rainfall period to make seed. Because if it bloomed late and the rain shuts off the 1st of April, which it can do quite often in California, and the soil dries out, the plant's not going to make its potential of seed that it bloomed out actually. So you looked at that, you looked at flowering period type of thing. Pollinator value, from our standpoint, a lot of times was observational. I'm glad to see that we now have a study that has pointed out some of these. Some plants are more valuable than others. There were some plants on that list that is like, I did not realize they could be valuable as a pollinator forage or a bee forage type of plant. So our observations would be walking through these fields in the spring when these things are all in flower and kind of observing, okay, there's lots of bees on that one, but there's none on that one. Why? So then we would investigate that type of stuff. So that would be, we'd eliminate, the next go around, might eliminate that because, yeah, it didn't do anything for us. So why put it in type of thing? The farm value goes into that. And by farm value, I would say is basically your soil health attributes you're going to get out of this type of thing. The brassica mix that we offer is also probably the number one choice for addressing water infiltration, because those brassicas make a taproot that helps open compaction layers up and makes your water infiltration go in. The nitro builder that we offer has flowers for our bees, but also basically is making biomass as an organic matter accumulator to put back in the soil type of thing. So the balance is, okay, which is my bigger problem? We go back to that first one. What do we want out of this? Well, we want bee forage, but the water won't soak in. So, okay, we're gonna recommend a brassica mix for the mere reason that that's going to feed the bees best early, and it's also going to make those tap roots to help open that ground up and let rainfall soak in rather than otherwise. And it applies on into the summer when they're putting on even drip irrigation, where the water, rather than puddling, gets out there and it hits where that cover crop was, it sinks in. It doesn't sit there all summer long type of thing. Terminability would be choosing materials that we know we can stop growth on. They're not going to grow back. The vast majority of cover crops in California are annual plants. Some of them can be a little more difficult to control in certain stages of growth. The older small grains get, the stiffer the stem gets, the easier they are to roller crimp, but the tougher they are to mow. If you would mow a small grain before it has basically initiated a seed head, even when you can't see it, there's still enough oomph there a lot of times that they'll want to grow back again. So terminability means we would like to have uniformity in when all that stuff's about right. That way we would maximize our biomass, we maximize our benefits, and at the same time we can eliminate all of it at the same time. Weed status, some cover crops are more better at suppressing or competing with winter weeds. Uh, a way to manage some of the summer weeds basically is a different management technique that we won't worry about today. But we want to look at something that's going to grow up and compete with those winter weeds real fast, which is why, people would say maybe we should just plant straight wildflowers, and they're not great competitors. So when they're small and seedling size, so they're not, you're going to put those in, but you're not just going to depend on them to compete with all that winter weeds that you have out there. Animal risks are, as grazing becomes a little bit more mainstream and people are more investigating in it type of thing, we hadn't got into it. The majority of the materials we would put in a cover crop are not going to be toxic to livestock. They're actually came over from the forage market. Oats and rye grain and things like that are annual pastures for a lot of the country, basically. So they weren't necessarily going to be a big risk. Some of the what I would call exotic stuff, we would have to look up. California poppies, for example, are considered toxic to some things. And then it's going to depend on what you're going to graze in there. Are you going to run cows, sheep, goats, fowl? They're all going to prefer something different out of that mix. So what they're going to graze on type of thing. And then basically, in almonds, especially, they're going to, if you put livestock in there, they're going to be in and out early in the season. Regrowth might be something you want out of that after that. If they're going to be grazing in January and you got to have them out by March, 1st of March, you might want to grow back just a little bit before you do your termination type of thing. Like I said, we were aware of it, but we weren't necessarily, it wasn't high on the radar list of things to think about. We would get asked, I'm going to graze this, so we would move things around and use more compatible, more feed type small grains and peas and things like that in cover crop mixes. For the most part, the brassicas, most livestock will eat it. There's no problem. I haven't heard of any toxicity problems with that.
As far as the brassicas go, they're really great forage and nutrition for things like cattle and sheep and goats, but they are toxic to horses. So it's important to know what you're planning on running through this cover crop.
Yeah, and well, in our weed status is also, a lot of people may have fiddleneck. We can compete with fiddleneck, but we can't necessarily stop it, and that one's definitely toxic to horses as well, as well as groundsel. So those are weeds. They're not necessarily, we're not planting those. So if that was your big issue, yeah, we would figure out a mix that would compete with those and that we would manage in time, basically, to limit the seed bank of those toxic weeds over time and beat them down to less. But it really and it's a great big juggling match basically going on there type of thing. And we're coming down to this grower's goals and what does he want to get out of it. We're supplying you seed. We would like to feed the bees. You're looking for better water infiltration, or you're looking for biomass, organic matter to either incorporate or to leave on the surface type of thing. You're looking for this, that type of that, and the next thing. Those would be things that when we interview a recipient or a grower, we're going to ask those questions. It's like, what do you want out of this? What's bothering you today? What's bothering you year round? So, okay, well, and then they would say, well, I want to try this stuff. And it's like, well, let's do this first and then we'll get to that. So that was people would want a reseeding one, but they weren't quite ready to do a reseeding one yet. They had some other issues they needed to take care of. And then there was, are you going to incorporate it? Or are you just going to mow it? Or are you going to do this? Those are a whole bunch of questions I end up asking on this type of thing that goes into that. And we narrow it down to, we're going to give you the best fit we can. So and when you're doing what we're doing for this, we need a mix that's going to work from Kern County to Shasta County, which is going to be a wide range of rainfall amounts, rainfall timing, soil types, management types, et cetera, et cetera. So, um, some people might want something really exotic in that thing because they like it, but it's like, yeah, we're not necessarily going to build that. We'll supply it to you. You can put it on by yourself, but we're not going to put it in our big gob of stuff we made because we've got this one that fits pretty much everywhere. I always called it throwing spaghetti on the wall and seeing what would stick. And in extreme situations, I had seen where, yeah, things were a mix with 8 things in it separated itself out where there was 3 real good ones at the bottom of the hill and 3 real good ones at the top of the hill and not a whole lot in the middle. So I hope I answered those questions.
You did. Let's go to the next slide.
So the testing and evaluation, and that was basically my job on that type of thing, on a lot of these development ones was trying to make these things uniform in their terminational and when they would be terminated. You didn't necessarily want something you didn't want a 2 small grains in your mix and one of them heads out real early and you mow it off and it dies, but the other one hadn't even gotten close yet and it grows back again. Can be a rude surprise occasionally, things like that. So you had to be aware of individual materials' typical growth pattern. That goes to compatibility. We used to call it, do they play well together? I alluded to wildflowers not being a great early competitor against weeds. Well, they're not a great competitor against bigger seeds as well. Most wildflowers are teeny tiny little seeds. And then how are you going to plant it? If you planting it with a grain drill that sticks at everything 2 inches in the ground, small seed's going to have a bigger problem coming up and growing through that. So that was another compatibility. Representation would be, excuse me, basically, we would also then look at those and we'd go, okay, how many seeds are in a pound or how big are the seeds? If we were putting something in that had peas and vetch and small grains together, we would look at it and go, okay, the peas are the biggest one, and we want to lean the hardest on them. So we would have a higher percentage by weight of peas, even though they had a lower seed count than the small grain did or the vetch did. Then you would then affordability get thrown in it sometimes, but that's what you had to do. Is I would have people that go, I want 30% oats and I want 30% peas and I want 30% mustard, and I'd have to point out that mustard has about a tenfold more seeds than the oats do per pound. And if you put that in there, all you would see would be mustard. It would come up and crowd everything else out. So we would have to kind of bring them to, you're still looking for this number of plants in a area. But you don't have to put on, when you're doing it by percentage of weight, you don't have to put on that big a percentage of that to achieve that. There are calculators out there that utilize pounds per acre, pounds planted per acre type of thing, and they can be probably better at that division if you're starting from scratch, because basically they'll, in that calculator, they'll also usually tell you how many seeds there is in a pound. And it's like, oh, I don't need to put 50 pounds. And they'll tell you, yeah, if you were planting this by yourself, you'd plant it at 10 pounds the acre. But, and that would be a solid stand of that stuff. If we want to put that particular material in with some other stuff, we don't need a solid stand of the mustard or the small seeded stuff. We need a stand of everything. So it boils down to, yeah, this mix that we're looking at here in this slide right here is, small grain in a canola or brassica rapa, and there's probably some peas in there someplace as well. The rapa is maybe 1%, and you planted it at 50 pounds per acre. Well, that's still close to what, half a pound per acre? That's plenty for what we want to get out of it. Unless I don't have my calculator, so it's like, yeah. And that would be another way you'd look at it when you were going, okay, what's my planting rate going to be? Am I going to plant it really thick? Or am I going to plant it fairly light? Maybe I want to increase that. Probably not. But on the other hand, that would be another thing in that compatibility representation thing. And then the growth is, yeah, they're cool seasons. So they're, you could plant them in August and put water on them. They'll come up and grow. They'll be a little confused. Um, and then there are within some of these materials, there are differences between what they would call a spring pea and a winter pea, or a spring triticale and a winter triticale. It really boils down to, I just called it a cold treatment. The plant had to have a certain amount of hours of chill, just like pistachios and cherries and probably grapes and a few other things out there, to make fruit or seeds or seed heads or try to reproduce. So putting a very cold tolerant small grain in someplace that never gets very cold, it's going to take a long time before it will bolt versus putting a spring type of material in. It would usually just keep growing. And it says, I'm going to make seed heads when I'm ready to do so. Some are faster than others on that. There's uses for that if you have a shorter window, but most of the time in almonds and perennial crops, we're looking at a 4 to 6 month window where we're growing this stuff. It's not like we got to have it as big as it can get in 30 days and be turning it under. So we would also be asking, okay, do you sure you want that compared to something that might be a little slower growing that be easier to control? So what I did for quite a few years was planting these things individually so that we could get that idea is like, okay, that variety blooms and heads, maximizes approximately here on the calendar. The one next to it is later. The one next to that's even faster. That way, that gave us the background to go, okay, we'd blend this with this and this, and we'd have something that it's all going to be about ready in the end of March. It's all going to be about as big as it's going to get. It might be even starting to decline by the middle of April. Okay, cool. It works together. It's compatible. They all grow about the same. Then it's balancing seed counts and what I would call early seedling um, competitiveness, viability. There's another word for it, but basically, basically how fast it'll grow. This is why we discovered that, yeah, you couldn't put mustard in with clover because the mustard came up and shaded the clover out, and the clover never made it. So I tried it for years and just couldn't quite get it to work. There might be a situation where, yeah, you went and mowed the mustard off early and the clover did come through, but a lot of times what happened was early on, the mustard shaded everything out and it just didn't, it came up and it said, okay, fool you on you, I'm going to die. It's too dark, it's too cold, it's too wet. So testing and evaluation, and we've done a lot of that over the last 10 years or so with these mixes as well, massaging them a little bit. At one time, we offered quite a few different options and basically kind of brought the menu back down for the mere reason that was like, yeah, some of these options sounded real good, but nobody really had the place where they were going to fit. Whereas we can use these mixes that we offer that will fit the largest amount of places and do pretty much what we need them to do. So every year you evaluated it and you also kind of went back and you looked at it. So, okay, can we lay our hands on that particular variety again? Is the price tag going to stay about the same? Maybe we don't need as much of that in that mix. Like I said, there would be times when all you saw was mustard and that wasn't all you planted. So, okay, well, that was way too much, guys. So that was the evaluating a lot of times. And that's done a lot in the spring. We're out tromping through fields, looking at things, um, talking to the growers, talking to the sales forces, getting their feedback on, did it do what you wanted it to do? Or do we need to do something slightly different? And the other advantage of doing that evaluation, whether you're a grower or consultant or whatever, is you get to look at that and you go, okay, that's doing what I think it wants to do. And the grower's telling you, yeah, it's doing what I think it wants to do. You're on the right track. But with the neat thing about having annual cover crops is if we did this year, we don't have to do it. It's not going to come back. We're not going to have to do it again next year. Unless of course you let it go too far and reseed itself. And that's usually, cover crop is a managed tool. So a lot of times it's not going to be reseeding itself.
Next slide.
Yes, please. So anyways, we're and this is a result of that evaluation and that testing that's going on all the time. The seed mixes that we know for sure that we're going to be offering in 26, we're still this to be announced over here on the B yard mixes is we've got evaluations in the ground. We're looking at them. We'll be looking at them closer this spring to see how well they all play together. The short mix would be clovers and flowers and forbs and things like that. And I basically planted them out so that we could see how well they'll play together. Will one outshine the other? Will I get flowers when I need flowers in April? And will it grow what we need it to grow? The pollinator brassica mix basically has been a mix in progress for 10 years. We started out with rapini. Somebody sent a bunch of extra rapini seed from Arizona to some of the original testers of this thing. It works great. Brassica rapa or rapini is the same as the canola. And then within canola or within rape, it's also called rapeseed. The same Brassica rapa is rapeseed. They're oil crops. The seed is pressed for oil. Canola basically has a lower uric acid content in the oil, which makes it available and useful for people, whereas the rapeseed usually makes better jet fuel than it does anything else. Camelina is kind of the same idea, basically. So within canola, you can have ones that bloom early, varieties or types that will bloom early, and then you could have types that are going to want a bigger, longer cold treatment before they're going to head. That, in our case, is going to affect when we have flowers for the bees. And we're shooting to have flowers in January, February, March. So we want something that's going to bloom as early as possible. White mustard is going to be right behind it in flowering time. Yellow mustard is going to be right in there. The daikon radish, which came to fame, oilseed radish, again, oilseed, daikon, they're not interchangeable, but they're not necessarily much different from each other. Daikon just makes the great big root that people sell in stores and stuff like that. It flowers right about halfway between the white mustard and a brown mustard, or what we're calling the yellow mustard right now. So we've got canola, brassica rapa, we got white mustard, Synapsis alba, yellow mustard, Brassica johnsia, radishes, which is a Raphius sativa, common yellow mustard, which is a Synapsis alba. And this year, basically, to add to our diversity, and it won't hurt anything, is we're putting in a spring triticale. Like I mentioned earlier, this brassica mix makes a whole bunch of taproots, which is like drilling a whole bunch of holes in the ground. But they're all tap-rooted. They don't have a really extensive sideways rooting system. Whereas triticale makes a fibrous root system. It's going to go a little more sideways, and it's going to leave finer holes in the ground when basically the top dies and the root channels all dry up because the roots are now dead. So what we're going to see out of this basically is as good, if not better, water infiltration post cover cropping, because now we have that many more exits for water to soak in. Planting rate's still going to be 10 pounds to the acre, give or take a little bit, because we're not putting a whole lot of triticale in there. The thing is, if it gets too flat, gets too head, it is a pollen shedder. I haven't seen bees on it, but I have seen a lot of your beneficial insects, which are also buzzing around out there, working on seed heads of small grains. They're pollen harvesters, or they're picking aphids off of it or something like that. So it's a diversity factor. It's going to come into play a little bit. Um, it'll help us spread our donated dollars a little further as well. That's that back to that affordability type of thing. It's going to help that out a little bit. The nitro builder last year basically was common vetch, triticale, radishes. And we're going to add a little bit of Lacey Facilia to it. Again, a diversity factor. Lacey Facilia is a fascinating little forb. It doesn't make nitrogen, but it makes real pretty purple flowers that bloom about the time the vetch does, if not a little bit earlier, which is going to be after the radishes do. So in this situation, our bee forage is coming off of our radish flowers, then our vetch and our Facilia. We're testing it. I've got it in trials at different rates and so on and so forth. The biggest thing is Facilia is a small seed and the other ones are pretty good size. So one, small seed, a little bit goes a little further, but two, if it's too deep, you don't get as much. Preliminary right now, I am seeing all four things in those little plots out there coming up and growing alongside of each other. So we have pretty good hope for that. And like I said, the Facilia is in there basically as a diversity factor and to add a little bit more floral and forage for that whole cover crop type of thing. So it's we're looking at that diversity because we're all the diversity factor in the cover cropping industry is that we're waking up to the fact that our soil biology is what's actually driving all this fun stuff, and everything likes something specific or something different. Facilia was also one of the strongest ones in the pollen and nectar strength testing that it was found. So that's why it's also in a lot. It'll be in the bee yard mixes for the mere reason that it works almost everywhere. It's a neat plant. It's a California native that was taken back to Germany and domesticated and then brought back. So it's used all across the United States as a bee forage. So it's a fun little plant. It's going to fit in with that mix particularly well, I'm sure. Next.
So this next slide is for discussion. I know the slides can be a little rigid, but Tom knows so much about the program and about the history. I set this one in to be a little bit more of a free form. Would you like to start off talking about a little bit more about how rapini why it was so attractive for starting our program, and then why it kind of fell off the docket?
Like I said, on rapini, it's a variety of Brassica rapa or rape. From what I understand, it's a delicacy as a leaf or a green, and then the seed heads, the unblooming seed heads would be used similar to like broccoli or something like that as well, and the stems. It bloomed early. My understanding was the original stalks that they started out with were coming out of Arizona, which indicates, now that I think back on it, indicates basically it was a seed production field that overproduced, and now they had available seed, relatively cheap seed. And the neat thing about it was it blooms early. There are varieties out there that they call 30-day. There's varieties that they call 60-day, and there's varieties they call 90-day rapini, which generally means about that many days before it's either edible or there's something starting to flower on it type of thing. It can be, I've seen it planted in August and work. I've seen it planted I suspect it could be planted in March and flower, probably in July if it has water. See, that's in our cover cropping situation. A lot of times we're using controlled irrigation, whether it's drip irrigation or micro sprinklers, more and more than solid sets or flood irrigation ever was. So when you look at that situation, you're going, okay, and you're putting a cover crop in, you have to realize you're farming two environments. You have an irrigated crop, which is your cash crop, and you have a cover crop in the middle, which is a dryland farmed thing. Yeah, it might get some water. It might get a little extra water out of the micro sprinklers or drip irrigation over there type of thing. But it's essentially got to survive on whatever falls out of the sky. That goes back to that. We were always looking for things that will flower and make seed with as little water as possible because in 20 something year, 27 years of working for that seed company, more than half of them were drought or less than average rainfall years. So it was always important that we were trying to do that early type of thing on that. So what kind of, and like I said, the thing with seed production is it can be boom and bust. There's demand one year, so everybody jumps in and produces some, and then that demand is now fulfilled, and there's a whole bunch sitting around extra, which is probably where this original stock came from. And the next year, basically in 14, the fall of 14, there was some around, but there wasn't near as much as there was in 13. And your production year is going to be you're going to use some of it that fall, but a lot of times you're going to need that seed production for the year after type of thing. So it's always you're ahead of yourself or you're behind yourself, chasing yourself around, one of the two type of thing. So, and then some years, everybody's talking about how great a corn year they had this year. The yields are so great and everything else. What was a good corn year? Rain fell, everything worked right, and the soybeans didn't like it. So the same thing happens in the seed industry as well. They'll have lots and lots of something, and then the seed barns will be full and of that stuff, and then it's like, okay, well, I don't want to produce any more of that type of thing. So the seed producers are always trying to balance how much demand do I have for this stuff. So the ryegrass market was always up one year. There's a whole bunch, and the next year the price falls out the bottom, and some of the other ones, and a lot of the seed is basically kind of like a commodity. They produce a lot of it. A lot of it's used, but on the other hand, if you overproduce it, you're going to be sitting on it for a while. They don't want to have to do that. So, like I said, the rapini supply kind of dried up. Well, got to looking at it, started looking at other things, and that's basically why we shifted over to using canola. It's essentially the same genus and species. It was just a slightly different variety. So what happens is then amongst canolas there are early flowering ones, which is what we try to use in our mixes for this type of thing because we're after that early flower. And then there are other ones that have to have more cold treatment and will bloom later. And then some of the other brassicas will bloom 2 months later. So you plant it all at the same time. So it's that was part of the testing process. It's like, yeah, well, that sounds great, but it doesn't do what we need it to do. So a lot of times that was like, yeah, it was a great idea, but it didn't work. Turnips in California bloom too late for most cover crops that basically in an almond situation where we're trying to have as low residue as possible on the ground. And you want to get flowers out of it. They're gonna flower late. So, but if you put it in, you're gonna graze it. Yeah, somebody's gonna figure out, hey, I like those turnip tops, and they're gonna eat all the turnips out of it. So it's back to that. What do I want to get out of it type of thing. So that's why we understand when these excuse me when these things bloom and how long they bloom. So the present pollinator brassica mix, if everything works right, you're going to have about a month and a half of active flowers out there because those plants will bloom and continue to push out flowers until basically they kind of run out of steam. They either say my water situation is getting too low, or my genetic says I'm just done. So, and the neat thing about it is I have to answer it every year. Mustard has yellow flowers and radishes have white flowers, but you'll have both of them out here. This particular field here, if I'm not mistaken, is buckwheat,
Um,
which is
I'm not sure about what's in this one. I want to say it was a canola. That's just because I think someone was talking about seed pollination.
Well, it's yeah, can't hardly tell, but um, there are some other flowers out there or other plants out there that are used as cover crops that would be bee supporters, but not necessarily going to fit in what we're doing with seeds for bees.
Mhm.
Nobody's going to want to go plant a summer cover crop in their trees if they're not going to be able to water it.
Mhm.
So, excuse me, that could be a radish field also due to the color of the flowers on it. Canola is going to have a really bright yellow flower.
Okay.
Radish may have a yellowish tinge, may have a purple or lavender tinge to its flower, but most of the time it's going to be white. Buckwheat would have a white flower and flowers fast, but you can't plant it until May when the soil warms up, so it doesn't fit almonds.
Mm. I tell you what, I am really looking forward to seeing the new mixes and how they're growing in your new plots. But I noticed we're starting to run short of time, so we should probably stop our webinar here.
Okay, and you can reach us or find us, and if you got questions or whatever, we're willing to give it a whirl and get you an answer.
Yeah, put a comment down at the bottom of the video and we'll answer it if we can, and it might turn into another webinar. You never know. Thank you everyone for attending.
Yep, thank you much. Hope you learned something.